Hi, we're back. We're going to do another example. This is from Section 12.2, homework number 12. It's called physical productivity. That's P. X is the number of bricklayers per day, and PX is the number of bricks laid down per day. And we want to find the function. So A is going to be, we have dP dx. Let's multiply out by dx. Let's multiply both sides by dx. So that's going to be dP equals 90 x squared plus 1 squared 2x dx. Take the integral, and here we have a chain rule. So we have a chain rule here. So we have our chain rule right here, and we have to define our term. So just we define. Here A equals 90, N equals 2, f of x equals 2x, u equals x squared plus 1, and du dx is 2x, which equals b. So we need b, we need u, we need all these guys. And we substitute in the chain rule. So y is going to be equal to 90. U, 2 plus 1, divided by 2 plus 1. Usually like to put a box around that. And f of x, which is 2x, divided by b, which is 2x, plus c. That cancels. So I get 90 over 3. Put the u back. X squared plus 1 to the third. Plus c. That is going to be 30 x squared plus 1 to the third plus c, and that's our p of x. Of course, we have to find c. Second part says find p of 4. Well, I can't find p of 4 until I find c. So, in order to find c, they must have given me other information. So let's see what's given me in the problems. So my next step is to put the answer back up here. So y equals, in this case, p of x. And that equals 30 x squared plus 1 to the third plus c. I want to find c. Okay, let's see what they give us. Okay, says when x equals 0, p is 0. So I'm given when x equals 0, p 0 equals 0. So let's substitute that in here. P0 equals 0 equals 30. 0 squared plus 1 to the third plus c. So 1 to the third is still 1, so 0 equals 30 plus c. Well, c is going to equal 2 minus 30. So now I can substitute for px. The complete solution becomes 30 x squared plus 1 to the third minus 30. All right, so that's part A. Now what about part B? Part B. Part B says to find when this is 4 bricklayers. So I'm going to substitute in here 30, 4 squared plus 1 to the third minus 30. Since I didn't devise this, it's not going to come out even. So 30, 17 to the third minus 30. 17 to the third. Wow, that's humongous. It's a lot of bricks. These guys must be sweating. I think it's a sweatshop. Let's see what we get. Use my handy calculator. Let's see. 17 squared, 17 cubed. By the way, if you notice, I changed the problem from what was in the thing, so it's a little bit different. So 4913 times 30. Okay, minus 30. So they laid 147,000 bricks in one day.
Those are some pretty good bricklayers.
Those are really fast bricklayers. I imagine they're robots. 147,000. 360 bricks. That's only 4 of them. So these guys must have had their Wheaties in the morning. Or they're hopped up on something. They're really, or they're manic depressive and they're in a high. One or the other. How many is that per bricklayer? Let's divide that and see what we get. 360 divided by 4. That's 37,000 bricks per bricklayer. All right. Well, the reason is I actually changed the problem. I added on a 2x, so be careful. It's not the same problem as number 12. I made it a little bit harder, and of course it gave me an unrealistic solution. It's a lot of bricks. If you can find bricklayers like that, well, they wouldn't last long anyway. They don't eat, they don't sleep. All right. So let's go on now. How much time we have left in this?
Let's see here. We're 8 minutes in.
So we have, we're only going to 13 now, right?
Yeah, something like that. We went over on the last...
okay, so we have 5 minutes left?
The last video. The videographer wasn't paying attention to the time codes.
He fell down on the job.
It's true. I was yawning.
Okay. All right. He got up early this morning, 11 o'clock.
That's right. We're gonna fix it in post-production though, somehow, some way. It might end up being 4 videos. I don't know.
Section 12.2 exponential integration.
I was not as efficient as the bricklayers.
Not quite. Now, exponential integration, there's also a natural log integration, which we don't do in this course usually because it involves absolute values. Then we have to talk about absolute values. And then the things get really complicated. You got to take logs, then go back to exponentials. So we really don't do that in this course. And we don't have time. So let's take an example. Suppose we have dy dx equals 5 e to the x dx. All right, so dy equals 5 e to the x. I'm sorry, it's dy dx is 5 e to the x. So when I multiply both sides by dx, I get this. I take the integral y is going to equal to 5 e to the x dx. Well, the trouble with these problems is they frequently and most of the time need a chain rule. So what I'm going to do is I'm going to give you a chain rule for exponential integration.
So I guess if we're trying to hit 45 minutes, we have 2 minutes left.
Okay, well, I'll just give them the chain rule then.
Yeah.
Okay, the chain rule is going to be, if I'm given equals a e to the u f of x dx, then y is going to equal to a e to the u f of x over b plus c. So there's your chain rule for your exponential. How much time we had?
Like a minute.
Minute. So if we want to do that here, this one's a pretty easy one, because if you have this here, notice you have a equals 5. U is usually the power, so du dx equals 1. There's no n here. There is no n here. So in this one, there is no n. And f of x, well, there's nothing there but a 1. So what does this become? For this one here, y would become 5 e to the u, which is x, 1 over 1, plus c, or 5 e to the x plus c. And I believe that's it.
Yep.
Okay. See you next time.